Hey, how you doing today?
Thank you. Getting some feedback on that helps me know if you are hearing me and things like that. So that was good. And let's see. I've got Zoom popping up here now, and I don't know why that's happening. So bear with me for a minute. Okay, so here we are, and we are being recorded. So that's good. And I see Jaleesa, and I see Amara, and I see David. Is anybody else out there? Okay, well, we'll just roll with what we have, and do it that way. Now, I did post in Blackboard, and you have to be a little bit careful how you do this because I think you have to open a different tab in your browser, but you can open and if you want to, you can even annotate the notes that I threw together. So I'm going to be sharing some things with you here, but you also have them, and they can be there as well. So I'm going to share my application screen, and so there you will see my screen, and I am going to go and open up what I put into your syllabus tab, and it is called I think it's called 3-1 Notes. So hopefully you've found that. And I'm going to go back to the very first slide here. I don't think I'm going to go into slideshow just because that is, sometimes that's not useful, and there can be other kinds of artifacts and things happening. And I hope you can share this. So we're going to open up with what I'm calling round robin sharing and questions. And you certainly can ask questions, but the first question I really want to ask is, how are you people, and how are the people in your circle? And so I remember that I had Amara, so I'm going to go to you first. So how are you and the people who are in your circle there? You guys doing okay?
Hi, yeah, we're doing great.
Okay, that's good. And great is really wonderful. And to tell you the truth, these days, that's even more remarkable, just because things are challenging, just all over the place. So anyway, that's good then. And do you have any questions that you want to ask of me today? And again, these are these are not private questions. I mean, if you have something personal, this is not for that. But anything for the good of the order, or are you okay?
I'm okay for right now. I think I don't have any questions.
Okay, be free to ask questions. And I think the way this is happening, when I'm sharing my screen, I'm not really seeing you raise your hand. So I'm just going to suggest that you shout it out if you have a question, okay? And that holds for everybody else as well. Okay, let's go to Jaleesa. I think you were here as well. Is that true?
Yes.
And so how are you and yours, the people in your circle there? You guys doing okay?
Yes, we're doing well.
Okay, that is good to hear. And do you have any questions that, for the good of the order, that you have at the outset here?
No questions as of right now.
Okay, that's fine. And the only other person that I knew was here is David. Now, some other people might be showing up and things like that. I really strive to be prompt at starting, so that I'll try to hold to that. So, David, how about you and your circle? You guys doing okay?
Yeah, I think everybody's doing pretty well. I got a couple people in my family who got COVID over the weekend apparently, or positive COVID tests, but I haven't been near them, so
Okay, well,
it's
I wish
interesting.
that I wish them well, because this is I don't know, it's very curious time, so I do wish them well. One thing that I did do And again, you all should feel, good about asking questions. But again, I'm going to suggest that you just kind of shout out your questions, because again, I'm on this screen. Just as a little bit of an update, I did grade the LSA 1s. Now, I want to talk to you just a little bit about that, and we are going to go over it today in a bit, but I did grade it. And so those of you who turned it in got 100% for that. Now, when you look at points, you're going to see that it shows up just like, I mean, 100% is a good score, but that shows up as 1 point. But rest assured that what I'm going to do is I'm going to take all the LSAs we have, and I don't know exactly how many we'll have, but I'm guessing there will be 10 or 12 of them. Or actually, let's see, we're a 12-week class and we meet 24 times-ish. And so that means really that we'll probably have 20, maybe 20 to 24 of these. But I will take that as a percentage, and that will be fully 1/3 of your grade. So it doesn't matter almost how many points it is. It just means that, it's sitting there, and that's, but it will be 1/3 of your grade. So it's good for you to do that. If there's anybody out here there, and I actually don't know if there is, but the late work is accepted, so you can turn it in late because it is 1/3 of your grade, so it is important. So, do turn it in, but I did mark those. And one thing that I am not good at in many of my classes, but I'm trying to do better in this class, is keeping up with that. I'm pretty good at developing lecture materials, but sometimes I get behind in grading. But anyway, that's where we are. So now what I'm going to do is I'm going to go and work through this with you. And so I'm going to talk about that. So that is the old LSA that we're going to talk about. Then I'm going to talk about the next LSA, and then we'll do some practicing. And you should realize that on the high stakes assessments in this class, I will ask you to do things that are somewhat like the LSAs, or like problems that we did in class. And so, if you stay current with all that stuff, you should be pretty in pretty good shape with the with the tests and things like that. So I'm going to go here, and I'm actually going to expand this a little bit, but I ask you about the 5-number summary for the sample of bear's weight, and I also asked you to submit a box plot. So, and this is the bear's file in the syllabus tab. Now, I want to emphasize that one of the things that we're going to find is there is more than one bear's file in the syllabus tab as we go forward, but this is the one that is not Chicago Bears. This is regular bears, okay? And one of the things that we're going to do beyond that, and this is looking ahead, is I'm going to ask you to use that data to find the standard deviation of the bears and the z-score for the bears, because these are new things that we covered, since that time. And so we will be talking about that in this context as well. Okay, so now I'm going to go to let's see, I'm sharing this here. Okay, so that's good. So that is in that. So I'm going to go and I'm going to be logging into Blackboard from the other tab to call this up. Now you still should be able to see my screen whenever I call up the other file, but I'm going to blackboardcod.edu. And I'm going to go to our class. And Amara, I'm going to call on you, but the only reason I'm calling on you is I'm going to make sure that you can see the Blackboard screen and that the Bears Excel spreadsheet is coming up on your screen. So just wait a second when it should be there, and then I'm going to ask you if that's what you can see, because I'm flying a little bit blind because I can't see what you can see. So Amara, can you see my my Excel spreadsheet with the bears?
Yeah, I can see it.
Excellent. Okay, now I'm going to assume that everybody else can too. And Amara, I'm going to try to not pick on you all the time. And by the way, I'm not picking on you. It's just I could be talking and no one could hear me or anything else. Okay, now a lot of times I want you to realize that depending on the question I'm asking, you might want to sort all these things, because pretend the bears had names over here and I were asking, oh, which bear is the oldest, and maybe I had names of bears or something like that, you might need the whole thing. But what I really just wanted to do here, I just wanted to do a 5-number summary, so I really don't need all the bears, although I'm going to get all the bears anyway. So one of the things I expect you to be able to do is I expect you to be able to sort the data. And whenever you're doing a box plot, one of the things you want to do is sort the data. And so I'm going to go over and I'm going to sort the data, and a custom sort is what I'm going to do, and I'm going to be sorting these bears by the weight of the bears. Those are cell values, and I could do it either way, but just to change it up, I'm going to do largest to smallest. And so what happens is now I've sorted the bears largest to smallest. And notice that I sorted all of this. And I think these are how many months the bears are alive is my guess. But anyway, we have the bears sorted there. But now we're going to think about how many bears do we have, because we want to find the median to start with. And actually, we found a couple things already. This number down here is going to be the minimum. That's the 26, and this is the maximum. And so there are 2 of the 5-number summary. But then I start on 2, and I go all the way down to 55. So that means what I have is I have 54 bears. So what I'm going to do is I'm going to say 54 plus 1 is going to be equal to 55. And then I'm going to divide that by 2. I'm going to say that I'm going to count down 27 and a half. Okay, now 27 and a half then, and I can count, but I also could look at this. And so what happens is 27 bears counting down would get me to, and I started in 2, so that is going to be 28. And this is 29. So these 2 scores are the ones that I'm going to look at the average, because it's in between the 2. Now, it turns out that the average is 150. That is the mean. That is the median. I'll just make note of that, that this is the median right here. But it's not either one of these numbers, it's this one. So it's the one that's halfway between them. And that will have a meaning in just a bit, because you see, the next thing I'm going to do is I'm going to find the 3rd quartile. And so what I'm going to do is I'm going to say how many numbers are below, or I guess I'm going to say above here, how many are above this median. And the numbers, the number of numbers that are above this median are 27. And so this is going to be 27 plus 1. I'm going to say this is equal to 27 plus 1. So that's going to be 28. And when I divide 28 by 2, I'm dividing this one by 2, I get 14. So I'm going to be counting to the 14. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so it's going to be this one. That is the 3rd quartile point. And then going the other way, I'm going to also be doing 14. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And so it's going to be that one is going to be the point. And so what I have is I do have the 5-number summary. It's going to be 26 is the minimum, 86 is the 25th percentile, 150 is the median or second quartile. This is the third quartile, and the max is going to be 514. And then if I want to do a box plot of this, and again, I am in Excel 365, and again, the version sometimes makes a difference. And so I'm going to insert a chart here, and I'm going to be looking at, let's see, this should have been 365, so I should have gotten a chart here. I should have gotten a chart that was, that's the box plot. And maybe I didn't open it in there. Maybe I didn't open this in 365. I thought it was in 365, but I'm going to, maybe I will copy this and I will put it in 365. I thought it was in 365 already. That's going to be a problem a little bit with me because I normally don't. So I want to open this in 365. This should be the 365 app, I'm hoping anyway. Looks like it opened the same file. Oh, here we go. Okay. So now I'm going to put this, I'm going to paste this there. And now I should be able to, I'm a little worried that says book 2. Maybe it didn't open in 365 again. But I'm going to enter and I'm going to go up here. Well, it did open it in 365. And I want to do a box plot. And so this is the box plot. And so that's what we should have gotten for the box plot. And you could make this fancy by putting titles and everything else. Now, this little thing up here, is an outlier because Excel decided that that point was an outlier, and so and that's the bear that's 514. Now, if you're just drawing the box plot, you could draw it up there, but Excel thought that was an outlier, so that's why it is there. I'm going to talk a little bit more about how you might determine if something was an outlier. So I'm going to copy this chart. So I'm going to copy this chart. I'm going to go back to the other Excel chart where I had the 5-number summary. I'm just going to paste it here. And so what you did should look something like this. Okay, so I'm just going to pause and I'm going to say, does anybody have any questions that they want to ask about this? Because I have not written your midterm yet, but I'm sure I'm going to ask you something about the box plots and 5-number summaries. So any questions?
Got 2 really quick questions then.
Hey, and David, thank you for that because I mean, again, it's useful for me to know. And even if somebody said no, I'm good. At least I say, hey, somebody's hearing me. So that's good. Go ahead, David, with your question, please.
Okay, so when you're writing the like the 5-number summary, it starts lowest to like highest, I guess. You know, like
well,
here's what string, right?
Yeah, but here's what I would, yes, and by the way, that's a nice technical term, string as well. Here's what I would really want you to do. Now, I realize I did it this way, but I would want you to maybe, and I'm just doing max, third quartile point, second quartile point, you could call that the median, I don't care. And then you do first quartile and min. And I think the thing that would be clearest is for you to do this. So what I would do with this, and I know you have that question answered already, but that's 26, that's going to be 86, I guess, and this is going to be the 150, and this is going to be the, whatever that number was it 236, I think? 236, and then we have the heavy bear, which is 514. Okay, so I think writing it that way would be clear no matter how you wrote it. Okay. And you might have had another question. I don't know.
No, I think I just this one.
Okay. All right. That's good. Anything else? Or are we good? All right. Um, well, now these were things that you were supposed to study, and we are going to do them together. Okay. And I don't actually need Excel 365 to do this other one. And I think I went back here, but here is something I would like for you guys to try to do. And again, it is okay if you can't do it, but it is also something that I would hope that you could do if you were able to study the videos I wanted you to do. So we're going to do a couple of more things with this. And again, I'm going to give you a short time to do it. And then, we'll talk a little bit about it. So what I'm doing is I'm still sharing my screen with you, except I'm now going back to the PowerPoint slides, which are down here somewhere. And I'm going to ask you to figure out what is the standard deviation. And it really, I should have said more than just a bears, because it's a standard deviation of the weight of the bears. Okay, and I know I changed this, but that's what I would want you to do. Okay, now I am going to show you something before I have you do that. And I think this is the fourth slide in my list. The fourth slide in my list is kind of a bit of a formula sheet. And one of the things I sometimes have on my exams is I have things called grace notes. And so grace notes, and before we have a high stakes test, I will tell you, yes, I have a grace notes. And there's another class that I'm teaching where there's statistics, and I've promised them, and I might end up doing the same thing with you guys, I don't know, is I give you a formula sheet like this. So it's part of your test. And so you might not have to memorize things here, but there are calculations. And what I'm wanting you to do here is I'm wanting you to actually grab this Excel file, and in another tab, and again, it almost has to be another tab because you want to still be here with me. But what I'm going to do is I'm going to ask you to compute, and we talked about that, and there were examples in the video. I'm going to ask you to compute the standard deviation. Now you see two things here, and let's see, I've talked to David and I've talked to Amara and Julicia. I'm probably going to ask you just to, in a moment, just to have somebody to be pinging off, just making sure that somebody is there. So this formula sheet is here. So you don't have to memorize this, but there are two things here. One of them is a population, and the other one is a sample. And when you look at these for the standard deviation, you see that, oh, there is a difference between the population standard deviation, which is a capital N, and the sample standard deviation, which is a lowercase s. Now, I'm going to ask Julissa a question in just a bit. And again, don't worry about getting it right or wrong. I'm just trying to figure out if somebody's still out there. But I'm going to give you an analogy, and then I'm going to ask, hey, with these bears, is this a sample or is this a population? Okay, but now I'm talking about this. And there are, well, I probably could have looked this up, but I'm imagining there are maybe 5 billion men in the world. So if I wanted to talk about the standard deviation of the heights of men all the world over, this number, capital N, would be 5 billion. And this would be a very difficult thing to come up with, because you'd have to try to catch all 5 billion and measure them. And by the way, by the time you got around to measuring them, some of them would have been died and some others would be born and things like that. So, that would be kind of a losing game. But still, this would be 5 billion. But if I just took the men at the College of DuPage, there are way less than 5 billion. And so that would be a sample, a subset of the men. So I'm going to ask Julissa, is these bears that we have in that database, is that a sample or is that a population, do you think?
A sample?
I agree with you. It's a sample because there's much more bears than that in the world. Now, actually, I don't know how many bears there are, but there's more than that, I'm sure. And I do know that some bears, in fact, are somewhat endangered species. Polar bears, we worry about them with global warming and things, but this is a sample. So anyway, what I want everybody to do is to leap in and try to calculate. And again, we're practicing calculation with Excel. We're going to do it together, but this is something that you learned in the video. So let's find the standard deviation. And again, the equation is here. And what this summation means is that means add them up and so on and so forth. So you're going to be using one of these two formulas. And so that is going to be what you do for the standard deviation. But then there's also, I ask you to find the z-score for the bears. Okay, now the z-score is also on the same sheet, and the z-score is over here, and the z-score was also something that was in the videos that you were supposed to watch. And so z is equal to x minus mu over sigma, or if it's a sample, it's x minus x bar over s. Okay, so anyway, there's two calculations I would like for you to do. And so I'm going to ask you to grab hold of Excel and give it a go. Try to come up with these, and then we'll do it together. And now I've kind of went all the way around again. So Amara, I'm going to tell you, I'm going to ask you to tell me, and you can just say, why don't you tell me I'm ready? Okay. And what that means is when you tell me I'm ready, I'm not asking you if you finished it or you gave up, but you just say you're ready to discuss it. Do you understand what I'm asking, Amara?
To be clear, we're about the formulas for population and sample deviation.
Yeah, but what I'm asking you is, like, let's suppose that you go to that bears database and you figure all this out. Then you could say, Jim, I'm done. Or if you go and try to do that and you struggle doing it and you're ready to give up trying to do it, and I don't mean give up in terms of give up forever, but just, you need to have some discussion, then you can say, um, um, that you're ready to discuss it. And don't say done or that, just say, I'm ready to discuss it. I just want to have one person out there, but I don't know how long this is going to take you guys, okay? So do you understand what I'm asking you? You're sort of my timer.
Yeah, I understand.
Okay, great. Let's everybody give it a go. And she will shout out when she's ready to have it discussed. Okay, everybody give it a go.
Professor.
Yes, you ready?
Yeah, I'm just kind of confused on how this is supposed to go. Do you mind going through it?
No, of course I do. Here's what I'm trying, and that's fine, okay? And that's why I was asking, and actually I don't know if that was Amara or somebody else. You see, I want you guys to have some time where you're practicing doing this stuff in class. And sometimes it's going to be really quick, other times it's not. And I got to tell you, I'm way better in classroom because I can look in your eyes. I could just tell. I mean, if somebody's sitting there and saying, I don't know what to do, I know that, and there doesn't have to be this kind of dialogue. So now what we're going to do is we're going to go through and compute this, okay? So now we're going to compute the standard deviation. And if you guys have questions, please ask. But one of the things you might want to do is go back and do some of this later. Okay, so here's what happens. Now, these weights, which is what we have here, the weights are going to be my xi. And you see these, so the first one is the weight of the first bear. So that is x1, the next one is x2, the next one is x3, the next one is x4, and so on and so forth. So that's why I call this xi. And this would often in your book or in notes, this would probably be an x sub I, but I'm just doing this. So that is xi, okay? But the formula, in fact, let's go back and look at the formula. So I'm going back to my PowerPoint slide and look what the formula is. The formula says to find this one here, what you're going to do is you're going to add up xi minus x bar, which is the mean, and each one of those I'm going to square them. Then I'm going to add them up and I'm going to divide by n minus 1, and then I take the square root. All right, so that's the formula that I would be using to do this. And that is going to be the sample standard deviation. Okay, so now I'm going back to Excel, but this is the formula that I am using right now. So I go back to the Bears database right here, and I need to get, so these are my XIs, I already have them, but now I'm going to have a column that's going to be XI minus X bar. Now X bar is also on that equation page, and X bar is the sample mean, and the sample mean is X bar, and that bar is on top. So that is add up all the scores or the bears' weights and divide by how many bears you got. So that's what we're doing here to get the sample mean. So we have to get the sample mean first. So I'm going back here to Excel, and I'm going to, and I think we actually may have done this last time. I think we probably did, but this is going to be equal to, I'm going to add all of these bears' weights up, and I'm going to, so I'm adding all the bears' weights up, and then I'm going to divide by how many bears we have. And I think I said that we had 54 bears. Is that right? I think so. So I'm going to say divide by 54. And so this down here is the X bar, or that's the average weight of the bears. Now I'm going to pause right here and ask, does anybody have any questions about what I did so far?
No.
Okay.
Following
And
along.
thank you for saying that, because that's good. Now this next thing is going to get a little bit trickier because what I want to do is xi minus x bar, but I want to pull it down. But you see, the only place where x bar is down here. So I'm going to be using absolute addressing to refer to this. And so what I'm going to be doing is I'm going to be subtracting this, and that is in column I 57. So that is in, that's column I and row 57. So you see, I'm going to get an equation here and I'm going to pull it down. So this is going to be equal to, I have to type equal. I'm gonna, well, I don't know if I can make this bigger or not. So anyway, I lose because there's a lot of data here. So I'm gonna click there. And by the way, pointing and clicking is better than retyping, because if you retype, you could make a mistake just retyping it. And so now I'm going to do a minus sign, and then I'm going to use absolute addressing. So that means I'm going to type $I, and this is going to be $, and I think I said 57 for that. Now that means that this is absolute addressing. I guess I typed that wrong somehow. Oh, yeah, I didn't type a second $sign there. I typed a percentage thing, okay? And so that's what happens. So you see this formula is, so I clicked there, but then I did minus, and this is where, this is the absolute address where X bar is. So now what I can do is I can pull this formula down. And you see I get all of those numbers. And as you saw in the video that you watched, some of these things are positive and some of these things are negative. So what we do to get the standard deviation, we're going to square all of those numbers. So we're going to square all of those numbers. Every time you write an equation in Excel, you use an equal sign. So this is going to be equal, and I'm going to click on this, and when I square something, I use the shift and the caret, which is on, it's shift 6, and then I'm going to hit 2. So you see this is going to be squaring what was in that earlier column, and so I get this number, and then I'm going to pull this formula down, and I've done all of those calculations. So I have that. Now let's go back and look at the formula for standard deviation. And remember, the formula was you take each data point, x minus x bar, whole squared, and then you add them up. So I need to add up that bottom, I needed to get the sum of all these squares. So I'm going to add up this squared column. So that's going to be equal the sum, and this is going to be, I'm going to put it in between there like that. So I'm going to add all of those up, and I get that big number there. But now this number, remember the formula, what I'm going to do is, and here's the formula again, I'm going to be adding all those up. I did, but then I'm going to divide by n minus 1, and then I'm going to take the square root. So I'm going back to my spreadsheet, and I'm going to divide this number by n minus 1. So I'm going to say equal. It is this, and n was 54, 54. So n minus 1 is going to be 53, because Julissa told us that this was a sample. Correctly, she said that. So I'm just dividing this by 53. I get this number. And by the way, this number is called the variance. This is the square of the standard deviation. And so that's the variance. I'm just typing this in so I know what it is. But then I need to take the square root. So this is going to be equal to, there's two ways I could do this. I could do this SQRT, and this is going to be the square root of, and then I'm just going to, I'm eventually going to point and click. I'm just going to click on this. And you see, so the standard deviation of the bears is here, and I'm going to write that that is the standard deviation. And the only reason I'm typing that is so I can find it. Okay, so now what we've done is we found the standard deviation of the bears. And so that is a calculation that we could do. And again, I went through the complete calculation. So I did x minus x bar whole squared. I added them up. I divided by n minus 1, and I took the square root. Okay, so questions about this. And again, these are things I expect you to be able to do, and you can see that you really are going to be forced to use Excel to do these things because there's too many numbers to do otherwise. So question, and in fact, I think I'm going to ask everybody, and when I ask everybody, I'm not picking on anyone. I'm just checking. I think there are only 3 of you here. And maybe somebody else showed up. I don't know. So Amara, are you okay on this, or do you have a question?
I'm okay for now. I think I just have
Okay.
to review it a few times.
Okay, but you were following what I was doing. At least you're saying you don't have a question now. That's good. David, how about you?
I think I'm following along. There's one part that I kind of missed you on, and it was how you got that variance number.
Oh, well, okay, the variance, and I'm going to go back. The variance may or may not be on your formula sheet. Well, okay, the variance was, what I did is I took this number right here, and I hope you can see where I clicked there.
Yeah.
I took that number and I divided it by n minus 1. And n minus 1 was, so I took that number and I divided it by 53, I think. Okay. Now, and in fact, if you want to know what I did, I'm going to go over here and I'm showing you something. I'm trying to teach you. And by the way, I'm not trying to teach you all of Excel. I'm just teaching you the things that are useful for Excel for this class, okay? But one of the things you can do in Excel is you have a formula button up here, and I can click on the formula button, and I can, now I have to look at it. I have to do a show formulas, which is the button over here. So I can show you the formula down there. If you look down here, then what you see is I clicked on K57, which is this one, and I divided it by 53. So, and sometimes if you're doing a lot of work, you may use it. Now I'm going to turn that off, so I'm back there. So anyway, David, what I did here is I took this one, so I typed equal, and then I divided by that to get what's called the variance. And the variance is the square of the standard deviation. Did I answer your question? Or not so much?
No. Oh, I'm sorry. I was clicking the wrong button. Yeah, no. So you got what divided by 53? That's from the count of all the values.
That's right. That was the count.
Okay.
Actually, it was the count minus 1, but yes.
The count. Okay. Okay. That's what threw me off. Okay.
And you see the formula, and this goes back to what Julissa told us, is that was a sample, so it's n minus 1. Okay? All right. So that is good. Okay. Now I'm going to do 2 other things with you right now, and there are power
Wait, I
functions.
actually do have a question.
Yes, go ahead. I'm sorry.
Can you scroll back to the top, like to J? I have a question for one of the equations that you
All
had to
right.
type in. It was the one with the dollar, when you had to type in the dollar sign.
Yeah. All right. So now I'm going to show you the formula here. Okay.
Yeah,
So I'm
if
in
I
the
could
formula, and there's a showing the formula. Now, when you see that, and I am going to make this bigger, but then I'll have to make it smaller in a bit. And actually that got confusing. Okay, but maybe you can see the formula here bigger. So I'm clicking on I2, which is this, and by the way, it has to be an equal sign, and this is I2 minus, and then this is absolute addressing. So I'm saying $, that means that I only go to the I, and it's $57. So there's only one place where I go to get that X bar. And you see, I'm doing that because I want to pull this down, but I don't want the X bar to change because that would be a bad calculation. I want each one of these to be Xi minus X bar.
Oh, okay. I see.
Okay, and Julissa, I don't think I got to you I was asking people if they had questions. Are you good with this, or do you have a question?
I'm good.
Okay, she is good. So that is good. Now I'm going to show you some more high-powered things um, with Excel. Now the reason I'm showing these high-powered things is so you can use them, but also you do have to know how to add things up and know how to square things and do all this, because I am going to ask you to do those kind of questions. But X bar was nothing more or less than the average. So you see, Excel has many built-in functions. And so the built-in function that I'm talking to you about here is, this is up here at this F sub X, okay? So I'm down in this cell, and I'm going to and I'm just going to call this the average, or actually I'm going to call it the mean, but it also is sometimes called the average because the mean is the arithmetic average. And now I'm here in this cell, but what I'm going to do is I'm going to click here, and I'm going to go to the average. So I'm going to use all of these in this menu, and I'm going to scroll down to get average. And you could just type average if you wanted to, but I'm going to scroll down and get it. And you see they always tell you what it is, so if you're having trouble remembering it, you can always check to see. But then I'm going to say OK. And you see it says, OK, you're finding the average of what? Well, I want the average of all of those numbers. That means I'm going to add them up and divide by um, uh, in this case. So you see what I'm going to do then is I'm going to go here. This is going to be the average, but then I'm going to be replacing this in here. It's the average of what? And so this is going to be the average of the xi's. Okay, so that's going to be the x bar. So I get that. I hit OK. And you see, oh, it's the same number. Well, of course it has to be the same number because I did this, but this is probably quicker. Now you might say, well, I'll just know how to do that. That's fine if you're finding the average, but sometimes I want you to do something else, and so you do that. Another thing that you can do is you can find the standard deviation using an Excel function. So I'm going to say standard deviation, but you have to be careful here because, and again, I'm going to click up here on the F sub X, and now I'm looking at all, and I'm going to find the standard deviation, but you do have to be careful because you have to know if this is a population or if it is a sample. Okay, so I'm going to be looking for, I'm going to the S's, and you can type it in. And maybe I should have just typed it in, but I'm getting close now. I really should have typed this in, but anyway, it's standard deviation. But look up here, I have standard deviation of a population is that one. And if you read that, that tells you it is a population. Or I can say I want the standard deviation of a sample, which is that one. So that's the one I want, is the standard deviation of the sample. So I click that, but now it gives me a dialog box, and I want, again, the sample was this. These were the X values. So I go up there and I hit this. And you see I got up the same number. And of course I got the same number because I did the calculation correctly. So what we've done is we found the standard deviation and the mean with brute force calculation, and we found it using Excel power functions. And so, and again, I'm just going to go around the room. David, I'm starting with you this time. Are you good with this, or you have a question?
I think I'm good with it. Yeah, it's just going to take doing it a bit.
Well, but I do want you to be able. But do practice some of this stuff because on the exam you're going to be asked to do this. And then let's see, Julissa, you good with this?
Yeah, I just think the more practice, the better.
Okay, but please ask questions if you have them now, and if you don't, that's fine. I'll take your word for it. And Amara, you good with this or no?
I think I'm okay with it now. I'm just confused on a couple of parts, but
Well, and again, it's up to you, But if you say, oh, let's do something again, we can do it again. So it's totally up to you, all right? But I'm
Okay.
happy to answer your question, so let me know.
Okay.
So right now I'm thinking you're okay, but if you have questions, you should ask them.
Okay. I'm okay for right now.
All right, excellent. Okay, now there's one other thing I'm asking you to do that's a review from what we studied, you know, on the thing that you studied last time, or the videos that you watched. And by the way, those videos are dense. They're very good, but they're dense. And so, you know, you watch it more than once, and maybe you go back and maybe you watch it once, and then you go back and watch it again, and you pause it, and you write down some formulas and things like that. Okay, I'm going back to my thing here. And oh, and by the way, this is going back to the discussion I had with David, I think. But you see, here's the variance written here, and the sample variance and the population variance, and that's just the square of the other formulas. So you know that's where those came from. Okay, but I'm going back to this one, and I want to find the z-scores for the bears. Now, the z-scores were something that you studied in the videos, and the z-score is this formula here. So the z-score is x minus mu over sigma, that's x minus the mean over the standard deviation, or x minus x bar over s. And since we're doing samples, it's going to be this one over here. But we're going to find the z-scores. And you probably remember from your videos that the z-score tells you what direction you are from the mean and how many standard deviations are you away from the mean. So we're going to calculate this z-score for all of the bears. So I'm going back then to the bears database. Here it is. Okay. But now I'm going to do this, and this is going to be the z-score for the bears. And I'm just typing up here z-score. I'm just using words just so I know what I'm doing. But now I'm going to have an equation for the z-score. And so what this is going to be is equal to, so I type equal, and I'm trying to make this a little bit bigger. Actually, maybe I'm going to make it a little bit bigger before I do that, just so you can kind of see what's going on here. I hope you can see this. Okay, so now what I'm going to type is this is going to be equal. Now I need parentheses here because Excel will do exactly what you ask it to do, and you see the z-score is x minus the mean all over the standard deviation. So you see I have to do the numerator first. So this is going to be xi minus, and this is going to be the mean. Now I just happen to remember that the mean was $, actually I screwed that up. This is $I, $57, because I have to use that exact addressing. And then I'm going to put the parentheses there. And then I'm going to be dividing this by the standard deviation. Now I have to remember where the standard deviation was, and I go down here and I look at the standard deviation, and that is in L, looks like it's L59. Is that 58 or 59? Actually, it's in either, but I think it's in 50. It's in 59 here. That's 59. Okay, so I'm going to go back up here, and I'm going to say this is $L, $59, because that is absolute addressing, because I don't want to pull it down that way. So you see, this is going to give me the z-score for all of these bears. Okay, so when I do that, then I get this. So this means that this bear right here, 514 pounder, is 2.71, actually closer to 2.72 standard deviations above the mean. Now I'm going to pull this all the way down, and you see I have that. And so you see some of these bears down here. This tiny bear was 1.29 standard deviations below the mean. So you see I've done a standard score here. And so now I've changed everything so it's relative to how many standard deviations I am away from the mean. Now I'm going to pause and I am going to poll you guys. I'm not trying to be rude when I'm polling you, and if you guys start getting really good at asking questions, I might stop doing this, but it matters to me. Your success is my success, so I want you to, understand what's going on. And Jaleesa, I'm talking to you first. Are you good with this or no?
Yeah, I'm good.
All right, David
Yeah, I think I'm good with it.
and Amara.
I'm good.
Okay, understand I do want your questions when you have them. Okay, all right, so now I think we're going to go and do some other things, okay? So we're going back, and now we're finished with that. And by the way, I came in armed with a lot more to do today than we might end up getting to, but that's okay. All right, let me go back up here then. Okay, so we finished this. So we talked about the low stakes assessment that you did, and then we did a couple of other things with it. We did the standard deviation, and we did the z-score, so that's good. Now the next thing I'm going to do is I'm going to tell you low stakes assessment number 2, and this is due, and I'm going to try to have these things due before our class happens, and I think I'm going to change this. I'm going to change this to be 3-3, and I'm going to say near noon. Now the reason I'm doing that is I do want you to work on this, but I also want you to have the opportunity to come to my office hours if you want. I have 2 office hours every weekday. One of them is 6:30 to 7:30 a.m. That is like early in the morning. And then I have office hours also from 9 to 10 in the evening. And you're welcome at any of those. And so you see, giving you this time, that means you would have my office hour tonight if you wanted to come to that. You would have my 2 office hours tomorrow, and you would have my morning office hour on 3-3, which is the next time we meet. Now that's just if you want to come and get help then, okay? You don't have to, but that's what I'm working to do. Now here is the assignment, and this is based on videos that I'm going to be assigning you. Or actually, this is something that we've already talked about because this deals with the normal distribution. So these are videos that I've already asked you to watch. One of the videos that you were asked to watch was about the standard deviation. A second video was about normal distributions, and the third was about doing normal distribution calculations. And this is about doing normal distribution calculations. And so I'm just going to read it to you, and I'm going to post this into the syllabus notes so you have it. So the number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate chip cookies is normally distributed with a mean of 1,262 chips and a standard deviation of 118 chips, according to a study that people did at the United States Air Force Academy. I would have hoped that there would have been things that they would have to do that's better than counting chocolate chips, but apparently they did it. Okay, so then I ask you questions. What is the probability that a randomly selected 18-ounce box of chips contains between 1,000 and 1,400 chips? What's the probability that a randomly selected 18-ounce bag of chips contains fewer than 1,000, more than 1,200, fewer than 1,150? What is the percentile rank of one that contains 1,475? What's the percentile rank of one that contains 18? And so on and so forth. So those are the questions. It looks like I have 1, 2, 3, 4, 5, 6. Looks like I have 6 questions there dealing with this problem. Okay, so that's the thing that we're going to be talking about. And again, I assigned you to watch these videos. And again, you want to try to understand those because those are very condensed lectures, but they are lectures. Okay, so So let's do some of these, and I'm going to try to keep track of what I did, but I've introduced that. So let's move to doing a problem that's similar to that, perhaps. Okay, now so here is, and looks like this is the 9th slide in your deck. This is an important slide in your deck because this is the normal distribution. And this was talked about, but here's some important things about this distribution. The first thing that is important about this distribution is at the top, it tells you what is the area. So this is a bell-shaped curve, and the area is that blue part, and the area corresponds to the probability, and the things that are inside the body of the table are the probability. And so this is a table that you will have in your grace notes, and I will ask you questions about that. And the thing that's along the outside of this table are the z-scores. So these are standard deviations. And so for example, this down here is minus 1.00 z-score has a probability of 0.1587. Now these are the negative z-scores, and the next slide, which is number 10, has the positive z-scores. And let's do a problem that's somewhat similar to the one that we were to work on. And I guess I'm going to do this. And so how are you guys with this? Are you remembering this from the video, or do we need to go slower? I'm really reaching out to you.
Yeah, we can probably just start here. Just go through
Okay,
it.
excellent. Okay. All right. Now what I'm going to do is I'm going to stop sharing my screen, and I'm going to I am going to share, but I'm going to share my whiteboard with you. So I need to go back to here, and I am going to share again, but this time I'm going to be sharing a whiteboard. So you should be looking at a whiteboard with me, okay? Now, please try to follow along because I talk about this in a little bit different way than they may in the video, but I think this is a very useful way to talk about it, okay? So one of the things that we will have is we will have an X space. And the X space is the real world, and this is where we have a normal distribution 0, 1. That means this is a normal distribution with mean of 0 and standard deviation of 1. Or excuse me, I lied. So this is a normal distribution with mean, and this is going to be the Greek letter mu, which is what we use for standard deviation, and a standard deviation of sigma. Then over here, I'm going to have a z space, a thing that I'm going to call z space. I'm going to make that a little higher, so I'm trying to make it look like it's parallel. This is z space. This is not the real world. This is the table in your book. And that's what I was just showing you was the table in your book. And this is the normal distribution. In fact, I'm just going to do n. But here, the mean is 0, and the standard deviation is 1. So this is in your book, and this is the real world. And these two things are joined by an equation that tells you how to get from one space to the other space. And the equation is z equals parentheses x, that was supposed to be a parentheses, x minus mu, close the parentheses, divided by sigma. Now, let's, okay, so, and okay, so that's what I have. Now, and so I'm going to ask you to please try to make note of this because I'm going to be referring to this, okay? Now,
Did
this
you,
looks,
oh, I'm sorry. Oh, okay. It
go
just
ahead.
showed up.
Yeah,
Sorry.
no,
I didn't see the formula. I just saw it now.
okay, and maybe I should draw one other thing, maybe more than one other thing. I'm trying to, wow. Okay, this goes both ways. Okay, so I'm making it like this. So you see, this goes this way and it goes this way. So you see, if I know Z, I can put it in here. If I know X, I can put it in here. So I can bounce back and forth between these spaces. And I use this to answer questions about normal distributions. Okay, now we're going to do a few problems with this, and we're going to be using our table, and we're going to be going back there. Now I am going to ask you to take a picture of this or write it down or something, because I'm a little bit afraid that when I go back to doing the other charts, this might not be here when I come back. And so, you know, do make note of this. So this is, there are only two things, and this is what you learned from your video. There are only two parameters that matter. It's the mean and the standard deviation, that's mu and sigma. And the mean in your book is 0, 1. And they're tied together with this. So this is kind of an important concept here is this one. Okay, now let's go back and do that. And I am going to ask you guys questions. And I'm not writing down whether you get them right or wrong. I'm just trying to have some interactivity here. And if you get it wrong, that means I didn't explain it very well, or that means, you know, I have to explain it more. That's fine. But I am going to ask you guys questions. And again, don't be intimidated by it. And it's okay for you to say, I really don't know. That's okay to say too, because I'm not testing you now. I'm just trying to have some dialogue. Okay, so now we're going back to my PowerPoint show. And here's my PowerPoint show. And we want to come up here, okay? And so the first one I'm going to look at is this number 6 that you can see up here. And I'm going to, and David, I am going to talk to you first. You and I are going to do this part C, okay? And so that here's what it's asking us. It says, determine the area under the standard normal curve that lies to the left of z equals 0.92. Now, David, what letter do I have here? Do I have X or Z?
Z.
Yeah, so what space is that going to be in, David? X space or Z space?
It's going to be in Z space.
Yes, and by the way, you might be saying, boy, Jim, you're asking me stupid questions. Well, I'm just telling you that I found when I've taught this many times that X space, Z space is useful for students to think about. So we're going to be using the table in our book for here, okay? And we want to be finding the area. Okay, so we're going to go back to that thing. And David, David, I'm staying with you for the duration of this one. Is that a positive number, 0.92, or is that a negative number?
It's a positive number.
You bet. So here we go. I'm going to this one. Now this is the Z table that is the positive numbers. You see, you don't have negatives flying about. And we said 0.92. Okay, so what I'm going to do is I'm going to look here, and it's 0.92. Now, right here, the second blue thing, I got 0.9, and the 2 is going to be over here. And so right here is what I get for 0.92. And David, I'm hoping you can read that number.
Yeah. I don't mean to cut you off, sir, but I'm still on the whiteboard, I guess.
Oh, well, that's useful, so I should fix that. I'm sorry. And thank you for telling me that, because I was not on the whiteboard. So I'm going back then to Blackboard, and yes, you're right, I am still sharing that. So I'm going to.
You're like, these are easy questions, but then I'm like, oh,
Yeah,
I can't see it.
Okay, okay. So, all right. So I think I can just say share application now. Yeah. Okay. Now I'm changing gears. Okay, so I'm going, oh wait, I have to stop sharing first. So I've stopped sharing. Now I'm going to share application. And David, this is going to make a lot more sense now than it did. Okay. So here is the question that I was asking you. Although, David, you were not as lost as you could have been, because you actually have copies of these PowerPoint slides there. Although I realize that could have been really confusing. Okay, so what David and I are doing is, and David, you can see the PowerPoint slides now, yes?
Yes.
Okay, so I'm looking here. And I know this is hard for you guys. This is hard for me too. Okay, because I don't know where I am. Okay, but anyway, I mean, mathematically, I know where I am, but as far as I knew, you were watching this. Okay, so David, you can see this number 6C was Z equals 0.92.
Yes.
And this is to determine the area under the standard that lays to the left of this. Okay, so that is a good thing. So we're finding the area that lays to the left of that. So now I'm going, and I'm still staying on the PowerPoint slides, but as David said, this is Z space. So this is in my textbook. It's nowhere else. So it's in my textbook. And so I'm going back, and this is in my textbook. And this is, and maybe I can make this a little bit bigger. I can. This is not too bad. Okay, I'm making that bigger, and hopefully that's bigger for you. So I'm here, but now I'm going to go up, and I'm saying it was important that they were saying this is a little bit, I got to be careful. So it was the area to the left of that number. So you see, that's the area that's in the body of the table, and that went to the other one rather than this one. But you see, this is the area to the left of that. So this is 0.9. So this is where I get up to the 10th digit. And then I go over to 0.02. And this is 0.92. And that is, it looks to me, David, that is 8217. Is that right? Or is 8212? I think it's 8212.
Yeah, 8212 it looks like.
All right, so that's the answer to that problem. Okay. Any questions about that one?
No, no questions.
Okay. Now I'm going to ask somebody other than David the next question. So I'm going back here to this thing, okay, and I'm going to make it smaller again so we can see it. Okay. Now I'm going to say determine, and I guess I'm going to go to Jaleesa. I'm going to go to you, if I may. And again, don't worry, I'm not taking grades on this or anything. It's just I have to have some dialogue. So you and I are going to do part B. And so it's determine the area under the standard normal curve that lies to the left of. And again, Jaleesa, I'm going to ask you some questions. Is this a Z or an X? And maybe she's not with us anymore. So Amara, I guess I'm going to ask you. So is this a Z or an X, problem B?
A Z,
That's right. So is this in Z space or X space?
a Z space.
That's right. So this is in your book. So we can use the tables in your book. You might say, well, the answer is always it's in Z space. No, it's not. Over here we have X's. Okay. All right. So this is Z equals minus 1.99. And I know these are silly, very easy questions, but is this a negative or a positive number?
Negative.
That's right. So we're going to be using this one. And it was minus 1.99, and we were trying to find the area to the left of this one. So we're going to be looking for minus 1.99. So here is minus 1.9, and we run our finger all the way over to minus 1.99, and I want you, please, Amara, to tell me what number do we find over here?
I'm sorry, Professor, can you ask that one more time?
I sure can. And I know you probably can't see my, I don't know, can you see my cursor? You probably can't. Okay, but you can see the PowerPoint slide, yes?
Yes, I can see the PowerPoint.
Okay, so now we're going down here. It's about halfway down. So go down this column that says Z and go down to where you see minus 1.9. Are you there? You see that row?
I see that row. So
And then you run your finger over to
0.3.
0.09, 0.09, because it was minus 1.99. Okay, so what number do you see here at minus 1.99?
0.0233.
Excellent. And that's this area because it was asking what's the area to the left of that. Okay. So I think we got both of you answering that well, and that's good. Now I'm going to go back and we're going to look at some other problems, okay? And okay, so we did problems on number 6. We did numbers B and C. And again, what we're practicing doing is doing things just in Z space. Okay, we're still doing things in Z space. And David, I'm going back to you because Julissa, I think I'm not sure if she's there or not, but I'm going back to you, David, just because I think you're still there. Okay, and David, can you see number 7?
Yes.
I'm going to ask you to read number 7 and when it says to the right of, and then you read part C. Please go ahead.
Okay. So it says determine the area under the standard normal curve that lies to the right of Z equals 1.78.
Now, okay, and that was excellent, and this is the question that you and I are going to do. But this is different than the question you did before because now it's the area that lies to the right, not to the left. So you see, this isn't what is in your book. You have to change it to get the answer for this. You see, it's different. It's to the right. So you see, this is fundamentally different, okay? And I'm going to ask you, David, and by the way, I'm staying with you on this problem C. Don't worry if you don't remember some of this stuff and things like that. I'm just trying to teach you, but the only way I can teach you this way is interacting with you, okay? So please do not be worrying about this at all, okay? Okay, do you know what is the area under the entire normal distribution?
No.
Okay, I will tell you what it is. It is 1. And that's one of the things that was in your video. Now, what they don't do is they don't say, oh, remember this, but they do talk about it. So the area is 1. And so some of you will probably end up going back and watching those videos again. But the total area is 1. Okay, now I'm going then. And David, is this positive number or a negative number?
It's a positive number.
So we're going to the positive piece of this, and it looks like this, yes?
Yes.
And that was 1.78. And so you see 1.78. So if I look up here at this picture at the top, David, the total area is 1, but the area that I see in the table is this, I'm going to call that blue. It's shaded some color. And so to figure out that other area, I take 1 minus that area. So David, again, I'm talking to you. So the total area is 1, but the table gives you the area to the left. So you have to take 1 minus the area to the left. Are you following me?
Yeah, so it would be like 0.78.
And you might have answered it completely already. That might be really the answer. I'm going down to 1.78, and I'm running my finger across here. I think it was 1.78, and I get, so when we're reading 1.78, what do you see in the table?
0.9625.
You subtract that from 1. And what do you get?
Subtract that from 1. That's like what is that?
You use Excel if you want. I would use Excel.
Yeah.
And by the way, it's good practice using Excel for that. And I mean, I can do that in my head, but
So
doing
like
it with,
0.037.
yes, it is. And actually, you rounded that off a little bit early. It's 0. It would be 375. Okay. So I mean, because if you take all of that, well, let's see. Maybe I did that wrong. Let me do
No,
that
you're
with
right. Yeah,
Excel.
it's
Oh, okay.
0.0375. Yeah.
Okay, so but you give me all of that. Okay, so you see, David, you have answered that part C. And again, what we're doing is we're practicing the problem, problems dealing with using the table that's in your book. And so that's over here. Okay, so we did part C with that. Okay. Now, Amara, if you're still there, and I hope you are, we're going to do number 7, and I'm going to ask you to read number 7, but you're reading part B for us, please.
So just like number 7, like determine the area.
Yes, yeah, and read into B. Go ahead.
Determine the area under the standard normal curve that lie to the right of z equals negative 1.59. Oh, sorry, you
That's
said
right.
b?
Z equal minus, it is Z
Oh,
equal minus 1.59. Now, this is good, but I want to say a couple of things. Number one, is this in Z space or X space?
I believe that is a z space.
You betcha it's in Z space. That means it's in your book. And another phrase that is sometimes used for the table in your book is the standard normal curve. Okay, and she read those words before too. Okay, now, and Amara, and I know I ask you guys stupid questions sometime. I'm very small steps, but that's okay. Is this positive or negative?
It's negative.
That's right. So you see, we're looking at this one that has the negative values. And that was, oh, damn, I don't even remember what that was. That was minus 159, I think, okay? Now, and what does this table show you? Does it show you the number, the area that is to the left of Z or to the right of Z? I'm looking at the curve at the top.
Left?
That's right. So we have to subtract what you get from the table from 1, yes?
Yes.
Okay, because they add up to 1. Okay, that's good. So now we're going to go down, and I'm going to ask you, and if you can make this bigger or something. I guess I can make it a little bigger, except usually when I make it bigger, it gets all goofed up, but we'll see. Okay, so you're looking at minus 1.59, and you're going to tell me what number do you find in the table? Minus
Well, we
1.59.
can round up to 0.6, 0.06.
No, no, you don't. Use the number that you have there, please. So it's 0.0559, yes?
Where are you seeing that? Or maybe I'm just looking at this wrong.
Well, okay. Go down the Z column until you hit the row that is called minus 1.5.
Okay, and then you're subtracting 1 from that.
No, no. You go down to the column, to the row that is minus 1.5. And then you go across to the column that has 0.09 in it. So you're going across the row that was minus 1.5, and then you're going down the column that is 0.09. And what number do you find there, please?
0.0559.
Yes, now you're good, but now you have to take that number from 1 because you wanted the area that was to the right of this. So take that number minus 1 and you have your answer. Go ahead and do that. And I would encourage you to use Excel with that. So what do you get?
0.9441.
Yep. Well done. Good job.
Thank you.
So you see the area to the right of that number is this. So that's good. Okay. Now I am going to assert, and I always know what time it is. We've got about 10 more minutes today. So I'm going to go back and we're going to say that we're good with this. Now, one thing I'm going to do is I'm going to go back and adjust that because I'm thinking you guys might not be ready to do that problem yet that I was asking you to do. Okay. And so, and that's okay. Don't feel bad about that because I'm feeling my way along with you and with this VCM kind of thing. Okay, so we go back here to this. So the thing that we've done, I'm going to make this a little bit smaller. So you see, we talked about using the table in our book, positive numbers and negative numbers to the left and to the right. So we've done all of this. Okay. Now we're going to do a different kind of problem. And David, we're going to go and talk to you about this. And David, I'm going to ask you to please read number 10, and you will read you'll read the part that says read number 10, but then read into part B, please.
Okay. So it says determine the area under the standard normal curve that lies between, and then B, Z equals negative 1.67 and Z equals 0.
Okay, so that's excellent, and that's what we're going to do. But now we're finding the area that's between two things. Okay, all right. So now I think I'm going to go back to the whiteboard. So I'm going to stop sharing this, and I'm going to try to go back to the whiteboard. So I'm going to be sharing something else, and I'm going to be sharing the whiteboard, and it says share blank whiteboard, but that's okay because you guys wrote some things down. David, you can see the whiteboard now?
Yes.
All right, excellent. Now, I'm drawing a bell-shaped curve, and I can draw a better bell-shaped curve than this, but not with the technology I have with me right now. Okay, now David and everybody else, remember that this is in your book. So this has a mean of 0. That's the center of the bell-shaped curve. And minus 167 is going to be over here. And we want to find the area that is here. And David, can you see where I'm shading that in?
Yes.
Okay. So that now, that area that I shaded in, David, is what relative to that top line area in this area? That is what I get out of my book. So the shaded area is what with respect to those?
Isn't it 1.67?
I don't think I asked my question very well. Okay.
Oh.
All right. Well, this is a symmetric curve. You learned that from the videos that you watched. This is a symmetric curve. So if the total area is 1, this area up here is 0.5. And this area you read from your table. And so if you look at your table, and David, if you could switch, and maybe you can't do that from your table, so I guess I'm going to, unfortunately, I go back to a blank whiteboard, so that doesn't take me, but I have to find this number right here. What is that area? Okay, that's what my table tells me. So I'm going to have 0.5 minus that area will give me this area. So what I'm doing is I am going back, and I am watching what time it is. Don't worry, I haven't gotten lost yet. So I'm going to go back to, I'm going to stop sharing this.
Same. It'd be like that. It'd be like that.
Martina, your mic is on.
Oh, I didn't know she even arrived. Okay.
Megan.
Okay. Yeah, I could have been calling on other people if I'd known that. Okay, so I'm going to stop sharing. So I have to go back here to the sharing thing, and I'm going to go to share application. Okay, and I'm going to stop sharing this one, and now I have to go back to sharing the application. And so I'm going to stop sharing this one. Then I'm going to share, and this time I'm going to share the application. And there. And so now what I'm going to do is I'm going to be looking at my PowerPoint presentation. I'm looking at minus 1.67, which is here. So minus 1.6 and 7, here's the 7. Minus 1.6 is the second one from the bottom. So this is 0.0457. So you see, this is going to be 0.5 minus 0.0475. Okay, so I will go, and I'm using Excel, and I've changed this to Excel. David, you can see Excel?
Yes.
Good. So this is going to be equal, and this is going to be 1. I'm going to subtract, and this was 0.04. I don't remember the rest of the numbers. Was it 57?
Yeah, it was 0.0475.
75. Okay. So I do that, and this is the answer to the question that you were looking for. So the area between those two is this one because it's the difference. Okay. Now we've got 2 more minutes, and so I'm going to say a few things. I'm going to change the due date on that low stakes assessment, and instead of having it due as soon as I was going to have it due, I'm going back up to the top. I'm going to change that one, and I'm going to change that to where it's due 1 week from today, which means it's going to be due on the 8th. Okay. But now I'm going to give you guys some advice. Okay. I think you really do want to go back and look at those videos I was asking you to look at, and look at them seriously, because all this stuff was in the videos. Now, I'm not criticizing you because we go over this, but make sure you study those videos. And I am also going to give you some additional videos to watch, because I want to continue rolling out material. But we're going to pick this up the next time we get together. Now, some students might find that they're struggling with this. No one has a reason to be thinking that they're struggling with anything yet. Those of you who turned things in got 100% on the low stakes assessment. Those who didn't get in grade at all, but you still can turn it in if you didn't turn it in yet. But what I'm saying is that nobody is bailing out yet or anything else. We're feeling our way, and you can do this, and we can be successful here. So I don't want anybody bailing out and say, oh, this is way too hard. It's not too hard. We're too early in the course for that. And so you will get there. Okay. All right. So, and I don't know who's all here. Amara, you okay?
I'm okay right now.
Okay. David, you're okay?
Yep. Thank you.
Martina, did she drop off or did she come back again?
No, I'm still here.
Great. Okay. Julissa, are you here, or did you drop out too? Okay, I think she maybe dropped out. I don't know if Sydney or Atlantis ever came. Okay. So anyway,
Weirdly, so
okay, all right. So anyway, hang in there, but watch the videos and pay attention to them, and review the notes that I hope you took today. And I'm going to stop the recording soon, and we'll be doing that. Okay, so we've reached 2:40. I know what time it is, so we're finished for the day. We'll meet again on Wednesday, and we'll pick this up from here. Okay, everybody know what you're about? Okay,
Yep.
Take care. Bye-bye.
Yep. Thank you very much. Have a good one.
Thank you. See you
Okay,
Wednesday.
bye-bye.
bye.
Okay.